So hi everyone. So in the earlier class we have solved the linear harmonic oscillator by Schrodinger method, where we have solved the equation linear harmonic oscillator by differential equations, right? So to avoid that, now we are going to discuss about the operator method or algebraic approach, which solves the quantum linear harmonic oscillator by factoring the Hamiltonian into ladder operators. So we can avoid the need to solve complex differential equations here. So, in the classical terms, we have defined we have defined linear harmonic oscillator. Linear harmonic oscillator Hamiltonian in a classical terms we have defined that p square by 2m plus half m omega square x square. So, in terms of quantum mechanical system, we will define Hamiltonian H, that is H cap is equal to P cap square by 2m plus half m omega square x cap square, where we are replacing the coordinates of PQ with, with the help of operators, that is P cap and x cap. So here we know that commutation of x cap comma p x cap, x cap comma p x cap, that is position and its momentum. Permutation of position and momentum is equals to I h cross into I cap, where I cap is an identity operator. So to solve this quantum linear harmonic oscillator, we will define two operators. So as we are discussing about the operator method, we will define two operators that that two operators will be dimensionless. So before defining those two operators, we need to find the dimensions of length in terms of h cross m omega. So the dimensions of length will be given as h cross by under root h cross by m omega, and dimensions of momentum are given by m omega h cap under root m omega h cross. So we will define two dimensionless operators here in terms of x cap and px cap. So the dimensionless operator a cap is an operator which is defined as 1 by 1 by under root 2 h cross m omega x cap plus ip x cap. Remember, a cap is equals to 1 by under root 2 h cross m omega x cap plus ip x cap, whereas a dagger is equals to 1 by under root 2 h cross m omega into m omega x cap plus, sorry, this is minus ip x cap minus ip x cap. So these are the two dimensionless operators you need to remember. So what we will do, we try to solve the solution. We'll try to solve the solution of quantum linear harmonic oscillator by using same Schrodinger equation h is equals to E psi. But we will find h cap in terms of quantum mechanical system in terms of a and a dagger. In terms of a and a dagger, we will try to find this h cap and we will try to solve. Let us do that. So where A dagger A are not Hermitian. These are non-Hermitian operators, but they are Hermitian conjugate. So what? This A and A dagger are not Hermitian, but they are Hermitian conjugate. So A dagger of dagger will be given as A cap, and A of dagger is equals to A. To find the Hamiltonian in terms of A dagger and A. So to find Hamiltonian in terms of A dagger and A, first we need to find A dagger into A and A into A dagger. So to find A dagger into A, we are multiplying these two terms, A dagger A. So we will get 1 by 2 h cross m omega in into m omega x cap minus ip x cap, because A dagger is his first term. So that's why we got minus ip x cap here. And A is other term, second term. So we are getting m omega x cap plus ip x cap from here. So again, if you multiply this bracket terms here, if you multiply these bracket terms, you will get this one 1 by under root 2 h cross m omega m square omega square x square plus px cap square plus I m omega cap px minus px x cap. As we know, commutation of x cap comma px cap is given by x, px minus pxx, and this value is equals to I h cut, isn't it? So just you substitute this value here. So we are getting px square plus m square omega square x square. We will rearrange the terms. So m omega into I h cut. So here I will be getting having some value. So I into I is I square, which is equals to minus 1. So if we substitute minus 1 value here, h cross m omega is removed. So we are getting this value. So that is 1 by 2 h cross m omega into px square plus m square omega square x square minus h cross m omega. So if you take out uh, 1, uh, 1 by 2m into the bracket, sorry, 1 by 1 by 2m into the bracket, what happens? This will be p square by 2m, px square by 2m plus m square omega square x square by 2m. You will get those terms. Let us see that. So here we are getting 1 by h cross omega is outside and 1 by 2m is taken into the bracket. That is px square by 2m plus m square omega square x square. So m gets cancelled and minus h cross m omega by 2m. M gets cancelled. Here we are getting px square by 2m is nothing but a kinetic energy and half m omega square x square. As we have just now seen that this is potential energy, that is px square by 2m plus half m omega square x square can be written as h cap. As these are operators here, as these are operators, this is what x cap. So that is Hamiltonian h in terms of quantum mechanical system. So here that is h cap by h cross omega minus half. H cross omega is, if you take out this h cross omega into the bracket, what happens? The numerator h cross omega and denominator h cross omega will be cancelled and you are getting plus minus half. So here a dagger into a can be written as h cap by h cross omega. Similarly, if you do for multiplication between a into a dagger, then you will get h cap by h cross omega plus half. So a dagger into a is h cap by h cross omega minus half. For a dagger, it will be plus half. So from these equations, from these two equations, or from the first equation, we can find h cap. That is Hamiltonian in terms of a dagger a. So if you take out half to the other side, you will get a dagger a plus half, and h cross omega to the other side, you will get h cap is equals to omega, h cross omega into a dagger a plus half. So before that, we can find by using these two terms, we can find a commutation relation here. Commutation relation is commutation of a cap a dagger, which is equals to a dagger minus a dagger a. So a dagger, you know the value of a dagger, that is h cap by h cross omega plus half. I have written, and a dagger a is having value h cap h cross omega minus half. So you are having this minus here. So minus into minus you will get plus, and this one is minus. So these two terms h cap h cross omega by h, h cap by h cross omega, h cap by h cross omega will be cancelled out, and we are remain with plus half, that is 1. So the commutation of a cap comma a dagger will be equals to 1, and a dagger a is equals to, as you know, h cap by h cross omega. From this we have found h cap here. So I have rearranged the terms and I kept h cap to the on the left, and we got the value h cross omega. This is from these two terms we can find. So from the Schrodinger equation, what we can write? We can write h psi is equals to E psi. So psi is nothing but here any state. Let us say keten state. So this keten state, h cap keten is equals to E cap keten here. E keten. So h cap can be written as h cross omega a dagger a plus half. So h cross omega here a dagger a plus half. This is the value you have. So which is equals to kitten. So now this is h psi is equals to E psi. If you multiply a dagger from left of to this equation, from left, what happens? You are getting this term h cross omega a dagger a plus half A dagger kitten is equals to En A dagger kitten. Just we have multiplied A dagger to this equation. So what happens in the next step? We can observe here we are getting the same equation when we multiply this A dagger. This is En. So here we are getting A dagger we have taken out and we can write A dagger A is equals to. Here A dagger A equals to we can write A dagger minus 1 because commutation of A cap comma A dagger what we got it is equals to 1 we got. That is nothing but A dagger minus A dagger A is equals to what? 1. So what is we are having here? A dagger A, right? A dagger A means we have to take out this 1 to this side that is minus 1 which is equals to A dagger A. So A dagger A can be written as A dagger minus 1. So A dagger minus 1 is written here. That's why so this value is this one. And if you take out A dagger into the bracket, what happens? A dagger will be remain into kitten state minus A dagger kitten plus plus half A dagger kitten, which is equals to this is which is equals to En A dagger kitten. And if you take out this A dagger kitten to the other side, which is multiplied with the h cross omega actually. So h cross omega A dagger A dagger A plus half into A dagger kitten, which is A dagger to kitten is taken as common for first and third term, and the second term is taken to the other side, which will give En plus half plus 1 h cross omega into A dagger kitten. So if you observe the first state where Hamilton H psi is equals to, sorry, Schrodinger equation H kitten is equals to E kitten, we are having H value as H cross omega A dagger A plus half and En kitten is nothing, En kitten here and we are multiplied with A dagger. We just need A dagger as extra term, A dagger as extra term, but here the energy is added with the H cross omega. So whenever A dagger is applied on any state, so we can say that whenever A dagger is applied on any state, the, the state will be increased by 1 unit or energy will be increased by 1 unit, which is added actually. So we are having H value. This is the H actually. So H kitten is there, but we have multiplied with A dagger, and this is the extra term we got. But what happens here on the next side, in the right side, we are having En kitten, just and A dagger is the extra term which we have multiplied. But we are getting another extra term which is H cross omega, 1 H cross omega, which is added by the operation of A dagger. So whenever A dagger is applied on any state, the state is increased by 1 unit. So this physically means that A dagger take the system lower energy to higher energy. So whenever A dagger is applied, the system is increased by 1 unit, or the system of lower energy is increased to higher energy. Repeating application of A dagger increases the energy by H cross omega each time. So this after that, as we just now seen, A dagger applied on any state K10, it will increase the state by 1 unit, that is n plus 1. And if n plus 1 is operated, I mean A dagger is operated on n plus 1 state, it will give n plus 2 state. And A dagger is applied on, let us take the state of 2, the state will be increased by 1, that is third state. If A dagger is applied on 100, the state will be increased by 1 unit, that is 101 unit. This is how A dagger will be useful. And next one is we will use the same Schrodinger equation, that is H keten is equals to E keten. Here, here keten is this one and H is nothing but we found in terms of A dagger A, that is H cross omega A dagger A plus half. and now we are going to multiply with a cap. So in the earlier case we have multiplied with a dagger. Now we are multiplying with a cap. So if you multiply a cap with multiply a cap from left, what happens? Equation will become h cross omega a dagger a dagger a plus half a into keten, which is equals to en a keten. So again, if you see here, you are having a dagger. If you take out a outside, I mean if you take out a common, you will get this one. So here you are remained with a dagger. This can also be written as a dagger can be written as 1 plus a dagger, because here if you see, this a dagger can be written as 1 plus, because this one if you take to the other side, what happens, this one is 1 plus a dagger. So this is what we have written here. So this can be written as 1 plus a dagger a plus half. So from this equation we can write the equation as a dagger a plus half a keten, which is equals to e minus 1 h cross omega a keten. So here we are taking out this first term 1 h cross omega a keten to the other side, that will be subtracted here. So h cross omega a dagger a plus half a keten, which is equals to this term a cap keten. Whenever if you observe the system here also, this is h actually, and which is operated on keten, but we have multiplied with a, and here we are having energy and a keten, but we are getting extra term which is minus h cross omega, means whenever a is operated on any system, state, the state will be decreased by 1 unit. So the state is decreased by 1 unit, or decreases the energy by 1 unit, whereas a dagger is increasing the unit of state or energy, and a is decreasing the energy by h cross omega here. So a dagger, that's why a dagger is called raising or creation operator. What we call a dagger as raising or creation operator, whereas a is lowering or annihilation operator, because it is annihilation operator, because it is decreasing the state of the system, whereas it is increasing the state of the system. If you consider this is the system of state of n, if you apply a dagger onto the system, the system or state will be increased by 1 unit, that is n plus 1. If you apply a onto the state, it will decrease the state by 1 unit, that is n minus 1 state. So these two operators are acting as a ladder to increase or decrease the state. That's why these two operators are called ladder operators. What we can call it as ladder operators, a dagger and a. Let us consider an example. Consider an operator of a cap square, which is applied onto the state of psi, which gives an eigenvalue of alpha and same state psi. So if you multiply psi state to this above equation, you will get this one, and we are considering this bra psi into a as xi, and ket psi into a as uh, a operated on ket psi is xi, and this value is equals to alpha. This xi and xi will be inner product of xi and xi will be equals to alpha, and which will be always greater than 0. So the minimum value of energy or state will be greater than or equals to 0. So always greater than or equals to 0, you can observe. So here the eigenvalues will only be non-negative. The eigenvalues will only be non-negative. So harmonic oscillator will also have non-negative terms. So harmonic oscillator will be also non-negative. So eigenvalues are non-negative. So harmonic oscillator eigenvalues will be non-negative. It is clear that energy get reduced by repeated application of A. So as we know, A is applied on any state, A is applied on any state, what will you? The energy is decreased or state will be decreased, right? So reduced by repeated application of A, it won't get to the non-negative term, but we will get a minimum state. So if I take an example of second state, what happens? A cap operated on this one will give 2 minus 1. That is first state, isn't it? So again, if the application of A onto the one state happens, what happens? This is 1 by 1 minus 1, that is 0 state. Again, if you do the application on 0 state, you want to go to the non negative state. I mean, it won't go to minus 1 state. It will be remain at 0 state only. So that is called the minimum energy state. That is called the minimum energy state. That is 0 or minimum state or ground state we will consider. And after application of A onto the 0 state also, it will give the 0 only. Okay. So energy eigenvalues can be found. So H cross omega A, that is H psi is equals to E psi here, but here the state we are decreasing taking as 0 state. So H is this one, H cross omega A dagger A plus half applied on 0 0 state, that is E0 get 0. So what happens? This state A, all are constant except this A dagger A. So A dagger A applied on any state, that is 0 state, will give A dagger 0, because after the application of A, after the application of A onto 0 will all will give 0 state, isn't it? So after the application of A dagger, it will give H cross omega by 2. So this is the minimum energy we can say. So 0 point energy we can say. This is what? A 0 point energy. 0 point energy for linear harmonic oscillator we can say. This is found by En is equals to n plus half h cross omega. This can also be found by En is equals to n plus half h cross omega, where if you keep n equals to 0, what happens? This value will become half h cross omega. This is what? This is a 0 point energy. So this is how we can find linear harmonic oscillator solution by operator method. I hope you have understood. We have defined two operators and we tried to find the solution of linear harmonic oscillator by using those two operators. And we have defined, firstly, we have defined H, and for the H, in the process of H, we have found A into A dagger value, that is equals to 1. And next, we found H and we substituted in H psi is equals to E psi. Here we are taken psi as, I mean, function as keten, that is E keten n H keten, and H value, you know, after the substitution once we applied A dagger onto the state, next we has applied A onto the state. So when you apply A dagger, the state is increased by 1 unit or energy is increased by 1 unit, and A is applied, the energy or state is decreased by 1 unit. So these two are called the ladder operators, which are used to uh, raise the raise the energy or decrease the energy. That's why we'll call it as ladder operators. Okay. I hope you have understood the class. uh, Thank you. Please like, share and subscribe to my channel.